The activity aims to help students to classify soil. The students shall be able to visually classify soil. The visual manual classify conducted in this experiment followed ASTM 02488 procedures, which emphasize using observable characteristics such as color, odor, texture, particle size, dry strength, dilatancy, toughness, and moisture condition to quickly identify soil types. This method is valuable during early site investigations because it provides immediate insight into soil behavior before laboratory testing. The experiment showed that coarse-grained soils are classified based on particle size and shape, while fine-grained soils are identified through consistency and plasticity to determine groups such as ML, CL, MH, ANCH. Previous STUs support the reliability of visual soil classification with Sanders and Seed, 1988, showing close agreement between trained visual assessments and laboratory results. Mitchell and Soga, 2005 holds, ETAL 2011, and Coduto, 1999, emphasize the link between soil capacity, mineralogy, and engineering properties, highlighting the practical value of rapid field classification. The U.S. Army Corps of Engineers 1992 further confirms that visual inspection, combined with sample manual tests, can yield dependable soil classifications comparable to laboratory methods. Resources: magnifying glass. Identify the soil color, odor, if any, and textures coarse or fine-grained. Identify the major soil constituent 50% by weight, using Table 1 gravel, sand, or fines. Estimate minor constituents using Table 1 and the following terms: trace 0 to 10% by weight, little 10% to 20% by weight, some 20% to 30% by weight, and 30% to 50% by weight. If the soil is coarse-grained, describe the particle distribution WELLGRADED, or fully graded, and particle shape CANGULAR to rounded using Table and 2. If the soil is fine-grained, perform the following tests: dry strength TESTDESCRIBE, the strength as none, low, medium, high, very high based on Tabule 3A, dilatancy test. Describe IFRAPID, slow or none, Table 36. Plasticity test. Describe it based on the criteria at Table 3C and D. Identify the moisture condition: dry, moist, wet, or saturated using Table 5. Record the visual classification in the following order: color, major constituent, minor constituents, gradation, and shape. If coarse-grained, plasticity; siphon-grained, moisture condition, soil symbol. The Table 3A is for criteria for describing dry strength. Then the Table 3B is for criteria for describing dilatancy. And Table 3C is for criteria for describing oil plasticity. This is the table criteria for soil toughness. Identification of inorganic FINEGRAINED soils and moisture conditions. These These are the classifications of each soil samples. The soil analysis from 3B or Orioles reveals similar soil conditions throughout the site. The surface layer consists primarily of coarse sand with a limited amount of gravel, indicating the soil is loose and permits water to drain easily. Beneath this layer, the soil transitions into medium sand intermingled with file sands. Deeper still, the soil turns clay blended with fine sand, which is more dense and retains water for longer periods.